Hello, in today's lesson, our learning target is I know how to write linear equations in slope-intercept form, and I can graph equations in slope-intercept form. So essentially we're going to be exploring slope-intercept form in lots of detail today. So in our last lesson we went over slope of linear equations and how to find it, what it is, just kind of a crash course on what slope is all about. Today I want to take a step back to the lesson before that, which was the basics of linear equations and graphing. So if you recall, we learned two methods of graphing linear equations, both of which are kind of the same. We have, if we're given 2 points, so if we're given the point, say, -4, -2, and 2, -6, if we're given 2 points and we want to graph a linear function, we just plot them. So we'd go -4, -2, we get that point over there, and then 2, 3, 4, 5, -6, we have this point over here, and we just connect them with a line. So a line is always defined by 2 points. You only need 2 points to graph it. And then we also learned another method, which is, say, if we have 3y minus 2x is equal to 18, we can find the x and the y-intercepts. So to find the y-intercept, we plug in 0 for x. So we get 3y is equal to 18. Our y-intercept is equal to 6. So on the graph, we'd have 6. Our x-intercept, we plug in 0 for y, so we get -2x is equal to 18, x is equal to -9. We just plot those points and connect the dots. So those are two perfectly valid ways to graph a linear equation. But we do have another way that I find really helpful, and which I personally find to be the fastest. And that is most useful if our line is already in slope-intercept form, which once again looks like this. So in slope-intercept form, y is our dependent variable. So y depends upon x, and you might also see this written as f of x. X is our independent variable. So m is our slope, and b is our y-intercept. So this form of an equation is really useful to us. It's really easy to graph, really easy to find the slope, and really easy to find the y-intercept, which are all things that are really important mathematically and that we'll be working with a lot in this unit. So I think in our last lesson we went over how to put equations into slope-intercept form when they're not in it initially. So we're going to jump right into graphing. So here we have some nice graph boards. So let's graph y is equal to 2x minus 5. So the first step is to identify what our y-intercept is. And so I'll write again, big letters, y is equal to mx plus b. So once again, our y-intercept is b. So our y-intercept is going to be -5. 1, 2, 3, 4, 5. Dot there. So we have 1 point. Now our slope is 2. So if you recall, our slope is equal to our rise over our run. We could also write as our change in y on top of our change x. So whenever you see a slope that's just a straight up number like this, it's implied that there's a 1 over it. So our slope is really 2 over 1. Which the way I like to think of it is we're going 2 up and 1 right. So I'll go 2 up, 1 right, and plot another point. Then from there, I'd go 2 up, 1 right, plot another point, and I would just keep going. And then I really only need 2 points. I'd just connect the dots, and we'd have the equation for our line. So that is a line with a slope of 2 and a y-intercept of -5. So now you might be thinking, what do we do if we get, say, y is equal to -4x plus 1, for example? Now our slope is negative. So we're going to go to our same workhorse formula that our slope is our rise over our run. Our slope now we can write as -4 over 1. And recall m is often used to denote slope. So what this means when I have a negative here is I'm still going to go right 1, but instead I'm going to go down 4. So first we'll plot our y-intercept, which is a +1. Now for our slope from there, we're going to go down 4, 1, 2, 3, 4, and right 1, and that would be our point. We could just keep going, and we get a line that looks like this. So I want to add in one comment. So this is how I like to think of writing the equations of lines, is you go down 4 and right 1. But you can also think of it as, we could also be going, say, left 1 and up 4, if we want to think of it this way. Because if we go left 1 from here and up 4, you'll see we'll get the next point, and we could have connected the dots with those points and gotten the same resulting line. So again, I like to think of it as going right 1, but if you want to think of it this way, feel welcome to do so. Additionally, you notice if a line has a positive slope, it's always going to be going up and to the right with positive x. And if a line has a negative slope, it should always be going down and to the right. So it might be a shallower angle, but it's always going to be going down in that direction. Whereas, so right, negative slope like that, right, positive slope look like this. So that's just a way of checking to make sure you know you did your slope right. Is if it's a positive slope, it should be going up this way. If it's a negative slope, it should be going down that way. So that covers positive and negative slopes. However, very often in slope-intercept form, we may see something like, say, -2/5 x plus 4. So if you have a slope that's a fraction, our y-intercept is going to be +4. So you can go up there. And our slope is going to be -2 over 5. So even though it's a fraction, we still use the same process. It's just we don't have to write that it's over 1. So I'm going to think of this as going down 2 and right 5. So from here, if I go down 2, 1, 2, right, 1, 2, 3, 4, 5, get that point, down 2, right, 1, 2, 3, 4, 5, and then I would just connect these dots, and we would get a line that looks like that. If we have, say, y is equal to 1/2 x minus 5, we do the same process, except this time our slope, we're going up 1 right 2. So I'll graph this one in blue. So our y-intercept is -5. We're going to go down 5. Then we're going to go up 1 and right 2. Up 1, right 2, up 1, right 2, up 1, right 2. So this line would look like that. So those are a couple examples of graphing lines in slope-intercept form using the slope and 1 point. So remember that finding 2 points on a line or making a table of values and graphing a line is still a valid method for graphing equations. So is graphing using the intercepts. This is just one other tool in your toolbox for graphing linear equations, and this is actually my favorite way. And once you get the hang of it, it's really quick. You can graph lines really, really quickly. So that concludes our lesson for today. So in our next video lesson, I think we're going to go over a different form of a line linear equation called point-slope form, which is really useful to us in other scenarios. And that's very applicable to parallel and perpendicular lines. So stay tuned for that.